Hello everyone, this is Hector, your AFM expert on Nanosurf, and today I'm gonna show you how to use sausages to obtain collagen. Um, First of all, you need sausages with a natural skin. Um, then what you do is you cut a little bit of it, and as you cut, it starts to peel off. Then you peel it off, and it's gonna come with a little bit of meat. That's fine because there will be places without the meat. Yeah, now it's happening. Perfect. I need a little bit of help. Yeah. Oh. Let's try again. This one didn't work. Oh yeah, the other part is here. Even better. As you can see, it's only the skin. I have a piece of glass here. So I'm gonna stand it over the piece of glass carefully, and the water is gonna help to keep it stick to the glass. Yeah, something like that. Hopefully you can see a little bit how it has been done, and if not, I have this microscope here where you can see the glass slide with the skin, and I'll show you in a moment how this looks like under the AFM. So yeah, see there is some residues, so we will look for a clean area, maybe something like this. Maybe here as well, it will be good. So I'll see you in a minute with the AFM results. I took the sample that I prepared before and put it in the drive AFM, clamp it, and then I used the optical microscope to look for a clean area. A clean area with the optical microscope looks something like this. You can see very large fibers in there. And then using wave mode with clean drive excitation, I took measured topography and error signal. This is a 3 by 3 micrometers scan, and you can see both the individual fibers and the elements inside of the fibers. So hopefully you find this interesting. Now you know how to prepare sausages from the supermarket to obtain collagen, and we'll see you next week. So I mounted the sample. There is a new wave motor probe mounted, and I already aligned the lasers. You should be able to see the two lasers on the cantilever there. and you should be able to see the sample underneath. I'm gonna move it now left and right. You see? There it is. We can put the light back up, and we can focus down again into the surface to try to find a nice area, something like that. As you can see, see the large fibers are relatively easy. They are everywhere. Any place is good for landing. They should be good. So I have selected wave mode. I'm going to be running it at 5 kilohertz, an amplitude of 200 millivolts, and we get an amplitude of 400. Seems good. Our set point is going to be 100 millivolts. If we want it to be more quantitative, we can run a thermal tune, and then we get the sensitivity spring constant. So if we apply that, now we can put our set point in newtons. 13 nanonewtons. Let's see. Probably is good. So heat approaching. It's going down to the surface now. We can track the progress in the monitoring window. And once it's landed, we will see the interaction curve with the surface, and we decide if there is if more optimization is needed. Okay, has landed. Let's check how the interaction curve looks. It's good. So it's almost flat. We have the interaction with the surface, and we have the ringing afterwards. We're going to scan 2 micrometers, 256 points, and the scanning rate is 2 Hertz. Let's see. This is the previous image. So it was a test image I took before. Let's see how the surface look like. Yeah, we're getting something. Let's use some flattening of the surface. Yeah, that looks better. On the left we have the error signal, on the right we have the topography. Let's see if we flatten it with another. Yeah, that is good. And you can see the individual segments on the fibers pretty well. We zoom out and we go back again into the live vision. Probably we want to increase the gain a little bit. Let's do that. Maybe more. And let's see if we can apply more force. So now it's 23. Yeah. Probably I'm gonna try to move a little bit to the right for the next image, because I can see that there is the fibers look good in that area. Let's try to focus better on the probe. Yeah, there it is. And this is where we are scanning at the moment. If we zoom in, we can actually, let's double click and then the zooming will be automatic. Topography, yeah. Can maybe look at the error signal, and then we do some flattening. Yeah, there it is. Yes, you see the top area is there is some contamination. There is nice fibers here or nice fibers there. So maybe I'm gonna add another scan down here. Let's do that one. And don't worry too much at the moment for topography tracking, because this is a very soft material, and there is some water, and well, it's gonna move underneath the probe. So but this is fine. We are not interested in that big topography. We are interested in the individual fibers. And there's very little to test here. It works straight away with standard parameters. We can try, for instance, instead of 5, we can try 20 kilohertz for wave mode. 200, yeah, that goes good. Let's see how the interaction curve looks like. So we enable the set controller. The probe goes into the surface. Okay, looks good. And then we should be able to scan a little bit faster. So I'm using 3 kilohertz now. And you can see that we are acquiring the same data, but now we can scan faster because we are moving the probe faster with wave mode. Yeah, can increase the gain a little bit. Maybe I want to have a look at there. I suspect this could be interesting. Just out of curiosity there. These ones I'm gonna add it in a queue, so I want to go this one first. Then I would like to scan this one, and the last one I will go here. And when it finishes, we start the queue. Yeah. And now it will sequentially scan all these different areas by itself.